Welcome back, Patriots. We're going to go ahead and get started on lesson 1 of unit 6. Now, right now it is, for me, 9:45 a.m. on Thursday before Thanksgiving. Turkey Day is 1 week from today. And I would strongly suggest to both my at-home students and my students here in class, guys, get this done as quickly as you can. You're not going to remember to do all of your homework over Christmas or over Thanksgiving break. So please get it done as quickly as possible. If you can turn it in before the end of the day on Friday, that would be best. But again, the due date's not till after Thanksgiving break. So, hey, if you want to wait that long, I guess you can. But the good news is also this is going to be a lot of review of Algebra 1. So you're not going to be missing a whole bunch. Now, for all of my remote students who are going to be printing their own things, just a quick word of caution wherever you print this one. Whenever you print it, the intention was for it to be a workbook, so you can fold it in half, and then this is going to be the back of the workbook, and this is going to be the cover, and then down here these would be the inside pages. So what you're looking for whenever you print it is an option that says to, if you're double siding, flip on the short edge, and that will make it print right. For my students who are here in class, I did not click that, so y'all's looks kind of funny and weird. But, all right, so let's talk about this thing first. We're going to be working on solving multi-step equations, no just simple 2x equals 4 a day. These are going to have a lot of multiple steps in it, and we've got a nice little flow chart for you guys to go through. Basically, these are the 6 questions you need to ask yourself as you're going through it. And yes, even after I've been solving equations like this for 20 years, I still ask myself these 6 questions every single time. Now, as you get better at it, it starts to kind of become more fluid, and you start seeing what steps need to happen in which order, but this is still the exact same order that I do it in. So, first thing you're going to look at is, are there any parentheses? And if so, distribute and simplify. Now, that simplify might mean you need to simplify things on the inside, like combining like terms, or you might need to distribute like that 5. If there's not, go on to the next question. Notice every single one of these, the option for no is go to the next line. Okay, then we're going to go through and look at, are there like terms on the same side of the equal mark? So over here, that would be like 5x and negative 2x. We're going to go ahead and combine those like terms. If there's variables on both sides, then we need to use an inverse operation to get to the other side. That's where we're doing things like subtracting 5x on both sides. That's my inverse operation. Is there a constant being added or subtracted? Now we're looking more like our 2-step equations back in Algebra 1. Again, use inverse operations, so it'd be like doing my negative 6. Is there a coefficient of x? If so, again, use inverse operations. Inverse of multiplying by 7 is dividing by 7. And then we got to decide how many solutions do we have, and we'll hit those when we come to them. So let's go ahead and go through this. Okay, so let's ask ourselves those questions. Any parentheses? No, none there. Do I have the same variable on this, or same variables on the same side? Well, it looks like I've got my 3x and my negative 7x. Let's combine those. 3x minus 7x is negative 4x. I've also got my negative 5 and my negative 16. Negative 5 and negative 16 makes a negative 21, and then equals negative 45. Okay, next question. Do I have variables on both sides of the equation? Nope. Move on. Do I have a constant being added or subtracted? Yes. So use inverse operations. Inverse of negative 21 is positive 21. That gives me negative 4x equals negative 45 plus 21 is negative 24. Now, do I have a coefficient? Yep. So use inverse operations. Inverse of multiplying by negative 4 is dividing by negative 4. Therefore, x equals 6. All right, moving on to number 2. Are there parentheses? Absolutely. All right, let's go ahead and multiply those through. So you got 2x, or 2 times 3x and 2 times 8 gives me 6x plus 16. Now let's distribute that negative 7. And remember, the negative sign has to be distributed as well. So negative 7 times x is negative 7x. Negative 7 times negative 2 is positive 14 equals 32. Now, do I have any like terms that need to be combined? Well, I've got my 6x and my negative 7x becomes negative x. Then I've got my 16 and my 14 becomes plus 30. The equals 32 drops. Okay, do I have a constant? Yes, I do. Which gives me negative x equals 32 plus 30 is 62. Oh, well, you know what? I said subtracted. Thanks for catching that for me. All right, so 32 minus 30 is 2. And now, do I have a coefficient of x? Well, this one's not as easy to see, but yes, that is a negative 1x. So we're going to divide by negative 1 on both sides, leaving me with x equals negative 2. All right, number 3. Exact same questions. Do I have parentheses?
Yes.
Yes, I do. So distribute the 1/2 and the 6. 6 times x is 6x. 6 times negative 1. Put that down here. 6x minus 6. 1/2 times 2x is x. 1/2 times negative 8 is negative 4. Okay, do I have any combining like terms to do? Nope. Do I have variables on both sides? Yes. Now I get to decide which one to move. And honestly, it doesn't matter. Typically, I prefer to move the one on the right because I like my variables ending up on the left. However, some people prefer to move the smaller one because they want to prevent themselves from having a negative coefficient. Honestly, I hope by this point dividing by a negative is not a problem for you on that very final step. So, like I said, I prefer to move the one on the right. Now, in this case, it kind of works out the same on both. Both of them will give you a I can't even think what I'm saying. It'll give you a positive. They're both the exact same idea this time. Okay, so 6x minus x is 5x. Minus 6 equals negative 4. Now I've got that constant to clear up. Negative 6. Opposite is plus 6. Gives me 5x equals 2. Now we're going to use inverse operations to divide by the 5. And so x equals 2 over 5. Technically, you could convert that to a 0.4, but you don't have to. Okay, number 4. When we got all these nasty fractions in here, I'm going to go ahead. This isn't on the flowchart because this is kind of one of those special cases that I don't think needs to be in the flowchart. It's just something you need to know. It's easy to do when you have a lot of fractions in there. If you were in class, I'd ask everybody to do this by a show of hands, but just answer this for yourself. Do you really, 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 really love fractions, or would you rather them go away as quickly as possible? Okay, if I ask that sort of question as a show of hands, most students are going to give me a show of hands saying that they really don't like fractions and they don't want them in there. So what we're going to do here is we're going to get rid of these fractions. Now the way you do that is by finding the least common denominator. Now when we look at 6, 4, and 12, my least common denominator or my least common multiple of 6, 4, and 12 is 12. So what I'm going to do is multiply the entire equation by 12. Now, that 12 is going to get distributed out to all of them. So, the equation that we're left with here is 5 times 12 is 60 over 6c. Plus 12 times 3 is 36 over 4 equals 11 times 12 is 132 over 12. Now, that did not help us get rid of the fractions, but it does make it so that every single one of those nicely divides. 60 divided by 6 is 10c. 36 divided by 4 is 9. And 132 divided by 12 is 11. And now my fractions are gone. So multiply both sides by the least common, or everything by the least common multiple, least common denominator. And all those fractions will magically go away. Also be careful on that. Remember that when you multiply fractions, and technically that's a 12 over 1. And so you multiply the numerators, multiply denominators. So that's why these denominators didn't change, because it was 1 times 6 is 6, 1 times 4 is 4, and 1 times 12 is 12. Then the 12 times 5 was 60, etc. Okay, now we can continue moving on. We don't have variables on both sides. We don't have any more parentheses. We don't have any like terms to combine, so now we're just going to move on. Subtract 9. Gives me 10c is equal to 11 minus 9 is 2. Divide by 10 gives me c equals, jump over here, c equals 2/10, which simplifies to 1/5. By the way, that very last step that we had on there, decide whether or not it has infinite, no, or one solution. If you get a number at the end, variable equals number, you've got one solution. When the variables all go away, that's when you've got one of the other special cases. Okay, number 5. First off, no parentheses to handle. We do, however, have variables on both sides. And like I said earlier, I prefer to move the one on the right using an inverse. So we got negative 2n on both sides. That gives me negative 5n plus 7 equals negative 15. Now we're going to clean up this 7 using an inverse operation. Negative 5n equals negative 15 minus 7 is negative 22. Now let's divide everything by 5, or by negative 5, and that's going to give me n equals 2 negatives make a positive. That's 22/5. Now, at this point with these improper fractions, you've got a few options of how you can write this. I know that many of us, we don't like improper fractions, but as long as they're simplified, there's really nothing wrong with it. You could technically also convert that to a 4 2/5, or this would also convert to a 4.4. Of the three, the only one that I really do not like is mixed numbers, because that makes it harder to do math on it later on. If I had to take that and substitute it back in, have it written as 4 2/5 is not nice. However, 22/5, I can do math on that. 4.4, I can do math on that. Either one is okay. I'm not going to restrict you guys on which one you have to do right now. Okay, number 6. I'm seeing a set of parentheses, so I'm going to distribute that first. 3x plus 3 equals 8x plus 1. Now I've got variables on both sides. I'm going to get rid of the one on the right. This thing give me negative 5x plus 3 equals 1. Now let's get rid of the 3. One minus 3 is negative 2. Divide by the negative 5 gives me x equals 2/5. And again, 0.4 there would also be an acceptable answer. I'm sorry? Yeah, so if you were to write that as x equals 0.4, that's also correct. Now, I don't want you to... The reason that I'm always hesitant to tell students that is because if I tell them I'll allow you to put decimals, then they just, from that point on, want to pretend that fractions never existed. Okay, I need you to be comfortable with fractions. Okay. Number 7. This one looks like it's going to be one of our more complex ones that we've done. Okay, first off, let's distribute. So 4 times x is 4x. 4 plus 3, or 4 times positive 3 is 12. That minus 5 drops down. 2 times 3x makes a 6x. 2 times a 3 is 6. And that plus 1 drops down. Now I've got some combining like terms to do with my constants. So I've got 4x drops down. Now 12 minus 5 makes positive 7. The 6x drops down. And then 6 plus 1 makes plus 7. Now I've got variables on both sides, so I'm going to move the one on the right. Give me a negative 6x. So that gives me negative 2x plus 7 equals 7. Subtract the 7 off of both sides. Leaves me with negative 2x equals 0. Divide by -2 gives me x equals 0. And students sometimes freak out whenever they get 0 as an answer. 0 is a number, just like any number. It's a special number. It's the only number that when you multiply gives itself back as an answer. It's also the only number you can't divide by. It's also special because it's called the additive inverse. Sorry, the additive identity. Okay. Oh, let's jump back to your Algebra 1 days. I'm sorry, your geometry days. All right, so what's the sum of the angles in a triangle? 180 degrees. So we're going to make our own equation here. We're going to say that 15 plus 10x plus 5x equals 180. And now let's take care of combining like terms. 15 plus 25x equals 180. Yes, I wrote 15. You just saw 25. I promise, I was right. No, actually what I was doing in my mind is I was adding those two. So, sorry about that. 15 plus 15x equals 180. Okay, now let's go ahead and subtract this 15 on both sides. Leaves me with 15x equals, let's see if I can do this math in my head, 165. Divide by 15, it gives me x equals 11. Now, the only thing that we didn't handle on this was this very last one of, do you have a solution? So I want to go back and give a couple of simple equations to demonstrate that. And I'm going to do them right here in the center. And I'm making these up as I go, so please forgive me if I screw something up. All right, let's take 2x plus 4 equals 2x minus 9. Okay, my first step, no parentheses, no combined like terms, I've got variables on both sides. So I'm going to subtract off 2x on both sides. And that leaves me with, well, these two here cancel out. These two here cancel out. I'm left with 4 equals -9. Notice that there is no variable left. That is one of my special cases. Now, we'll talk about what that special case means in just a second. Let's compare that to another equation. 4x plus 2, no, let's go with plus 12, is equal to 3 times, nope. 4 times x plus 3. All right, my first step here is distribution. I've got 4x needs to be distributed across, so I've got 4x plus 12 equals 4x. 4 times x is 4x. 4 times 3 is 12. Now we're going to collect our variables on the same side, and once again they canceled on both sides, So now I'm left with 12 equals 12. In both cases, I have no variable. However, these two are very different beasts. And the reason is that this one is a true statement. 12 does equal 12. This one is a false statement because 12 or 4 does not equal negative 9. When I end up with a false statement, that means I have no solutions. Whenever I have a true statement with no variables, that is infinitely many solutions. Now, for a single variable inequality, you could also write that as all real numbers as the answer. And we'll cover more variations on that stuff later. But for now, if you get either of those two weird cases, just make sure that you're handling it appropriately. So that's all I got for you for now. Remember, get this assignment done as quick as you can. That way you don't trail it off over Thanksgiving break. And I'll see you guys after the break.